Hello science students, my name is Mr. Hugus and I'm going to teach you how to format your lab reports for this semester.
I'm Ms. Matson and I will be showing you how to take the results and data that you have collected in the lab and enter it into an Excel spreadsheet, and from there produce a graph of the data points.
And I'm Mr. Helty. I'll be showing you how to format your graph, insert a trend line, and also how to insert and understand a R-squared value.
Hi, my name is Mr. Hugus, and I'm going to go through creating your lab report. First, put your name on it. If you don't include this, you won't get a grade. Below your name, write your class name and the date you created it. Title. This is the first thing you should write in your lab report. The title should be short, but it also should accurately represent the experiment you did. Below the title, be sure to include your lab partners' names. The abstract. This is really the first written section of your lab report. It should be a brief summary of the entire report. It should be roughly 100 to 200 words, and it should include a purpose, the key results, the major discussions, and the main conclusions. The introduction. This gives necessary background information you need for the experiment. Do not plagiarize. Cite your research as directed by your teacher. This section includes the purpose or objectives, the background theory, and your hypothesis. The materials listing. This is a very simple section. All you need to do is list out the equipment you needed to complete the experiment. This can be listed in a bulleted format. The procedures section. This includes all of the steps you took in order to complete the experiment. This should be detailed enough so a person who has never done the experiment before could replicate what you did. The results. This includes all of your raw data, important results written as complete sentences, and example calculations. This is not where you discuss your results. That is the next section. The discussion section. Compare and contrast your expected results with actual results. You can analyze your experimental error in this section. This is really the most important section of your lab report. This is where you tell us what happened and why you think it happened. The conclusion. This is a brief summary of the definitive conclusions you came to. Be short and concise. Finally, your references page. This is an alphabetical listing of outside sources you used in your report. Resources should be cited using the format designated by your teacher. Do not plagiarize. Thank you. I hope this helps in creating your lab reports this semester.
To begin making a graph for your lab report, you should have the results that you collected in lab with you. It is now important to identify the independent and dependent variables of your experiment. The independent variable is the variable that you control as a scientist. The dependent variable is what you are measuring in the experiment. The dependent variable depends on the independent variable, so therefore the dependent variable would not exist without the independent variable. Begin by entering the data into an Excel file. Organize your data into two columns. Let's call them the independent variable and the dependent variable column. Let's say for this experiment, our independent variable had the values 2, 4, 6, 8, and 10. And let's say that the data we collected in lab gave us the values of 1.9, 2.1, 3, 3.9, and 5.1. To plot this data in a graph, select the top left corner of your data, drag through with your mouse, highlighting the data, and go to the Insert tab. From there, click the Scatter button and select the Scatter with Only markers.
The next step in creating a graph, what you need to do is include a title for your graph as well as axis titles, so you can understand what information is going where. In order to do that, you need to click on the graph itself, and you'll see these three icons pop up onto the right side here. You want to click the one that looks like a plus sign. You get a lot more options for your graph, and you need to select these two right here, chart title and axis titles. Now you need to name your graph, and it helps to name your graph after what your variables are. Just so everything is nice and clear, anyone who reads your graph knows exactly what you're going to be doing. And how you make your title is, if you're basing it off of your variables, you have to set it up in the variables that it's going to be and how it's going to be read. So, as you may know in class, you know that you read a graph as y over x, rise over run, and you need to express your title of your graph in the same manner. So in this situation, because our y-axis is going to be our dependent variable, and our x-axis is going to be our independent variable, we would write our title as dependent versus independent. Doesn't that look nice? Next, you need to label your axes so that anyone who's reading your graph knows what information is being displayed. So anyone who looks at your graph can figure out, oh, this is exactly what this person is doing. So as we said before, our x-axis is going to be our independent information, so independent. And our y-axis, next, you need to help for whoever's reading this, you need to demonstrate to them that your data is not only true but accurate. In order to do that, it helps to include with your data a trend line. A trend line indicates an average direction of data. Essentially, it helps show any patterns that might be present in your data. It would be a simpler way of looking at it. And just sort of looking at the data now, you can kind of see a pattern where for every 1 approximately, in this case it's 2, but here after that it's more 1. Every time it goes up 1 for a dependent variable, it goes up 2 for the independent variable, or in this case right. So up and right. But to make that more graphically represented, we include a trend line. And there is your trend line. But while the trend line itself indicates a good general idea of what the overall pattern is, if you want to get more specific about how exactly accurate your data is, more specifically how well it conforms to this straight line, you have to include one more piece of information. And to get that piece of information, you need to go back to this trend line, in case you forgot, in case you accidentally click out of here, click back into your data, go back over to the plus sign, click that, go all the way back down here, trend line, you see this little arrow right here. Click the arrow, and you get more options, but you need to specifically click the More Options button in the More Options section. Sounds like a bad joke, but either way. And now you get this lovely box here to the side. I keep gesturing at the screen even though I know you can't see it, but that's okay. And all the way at the bottom, you see display R-squared value. It's very important to include this with your data. R-squared value indicates how well the points fit to a line or curve. In this case, we're looking at a line. Maybe a simpler way of looking at it would be to think of R-squared as sort of a roundabout percentage, where multiply that number there, say, in this case it's 9.9551 by 100, you can say that the data conforms to the straight line about 95.5% of the time. That's really close. It's pretty good. data is fairly close to a straight line. If it was perfect, that number would say 1 or 100%. It would be absolutely perfect straight line.
Are we recording?
I think so. Yep, we're recording. Hat on or on?
I think they're good.
Okay.
Right? My son can start. Hello, science students. We are going to teach you how to
Oh well.
This is a bad idea.
This is a
Hey, Abby. Hi. How are you? Good. What are you doing?
We're recording right
Filming.
now. Yeah.
It's alright. They have a blue wheel at the end or something.
Hello, science students. We're going to teach you how to correctly take your data from your experiments and format a graph and to correctly
I think we
build
should
a
wait a few
graph.
minutes.
Yeah.
I'm just gonna go stop the camera and
Okay, just
delete
delete
that
that
one
whole
because I don't ever want to see
Oh, leave it
that.
on there.
I don't want to see it.
I
How do you
do.
stop?
I don't want to see it.
How do you
I'm gonna
stop?
tell you.
How do you stop?
I don't want you to delete it. Edit.
Hello, Stipes. Oh, I hate this stuff. I hate this stuff. My name is Mr. Hugus.
I'm Mr. Healthy.
And I'm Miss Matson. Today I will be telling you guys how to take data that you've collected in your laboratory, in your lab experiments, and I'll have you guys formatting. I'll have you guys entering the data into an
Awesome.
Excel. Oh,
It's alright. If we mess up the line, let's just start
Just
from the
pause.
beginning.
Okay.
Yeah.
Did
Recording.
I say it right?
Yeah, you're good.
Alright. Again.
Hello, science students. My name is Mr. Hugus, and I'm going to teach you today how to correctly format your lab reports for the rest of the semester.
I'm Miss Matson, and I'm going to have you guys take your laboratory results and enter it into an Excel spreadsheet. I'm done. I'm sorry.
It's not fair, I know.
Good.
Yes! We are that
Good.
good.